chemical properties of alcohols. It shows two kinds of properties, that is nucleophilic as nucleophile and as electrophile. Two kinds of properties, as nucleophile and as electrophile. Right? Then accordingly, first of all, nucleophilic nature as nucleophile. As nucleophile, the nature of this is R O H. And here is carbocation. There is H C H. This is a carbocation. It is electron deficient. It has a lone pair electrons. The lone pair 1 and the lone pair 2. So it will attack as a nucleophile on the carbocation, and you will get R C R O, then R O H C H and then H this way. So this N plus deprotonation later on. And later on the deprotonation takes place in next step. These are deprotonation R O and C H H plus HR. This step is called deprotonation because this carbocation, when it will gain the electrons from ROH, the addition of electrons here, nucleophile, and this hydrogen will give its electron to electron deficient oxygen as it is more electronegative, and this step is called deprotonation. Deprotonation. So this kind of reactions are called nucleophilic reactions. Next one is as electrophiles. As electrophiles. By this method, I mean to say, you will experience two kinds of chemical properties of alcohols. Here is R CH2, or lone pair of electrons here, H. Now, what is this proton? This proton, it will come to this R CH2O H and then H. Now these protons will be shifted to another compound. This is shifted to this, and H2 moved out. RCH2 and then H2O. That is dehydration. Dehydration takes place. Now, in next step, plus nucleophile attack, Br. So it will attack at this, and you will get CH2 Br. So in this reaction, ROH acts as electrophile. In previous reaction, it acts as nucleophile. Then example of this one is C2H5OH, then acetyl chloride CH3COCl. When it will electron deficient, that carbocation, it will take nucleophile from OH in presence of basic medium, base, generally pyridine used, then C2H5O similarly, and then H as you know, then CL, and then CH3, and here is O. This is the oxygen. In such a way, this oxygen, whatever got the electron, it will return it to back. This moves out, and you will get CH3, COOC2H5 plus HCl. This is the example of nucleophilic attack of the alcohol, ethanol. Ethanol will attack on ethanoyl chloride. Ethanoyl chloride, it is a carbocation in such a way C2H5OH, CH3COCl, CH3CO, then C2H5. So this is esterification. You will go to the ethyl ethanoate. This is the ester. Right? Now, in the next reaction, you got this direct example as an electrophile. This is proton. This proton it got from acid, and that is alcohol. It acts here electrophile, and it gains the electron from the proton. It is released by an acid. This proton comes from H2SO4, H and plus HSO4 in aqueous state. So this proton is utilized here as a proton. Now, question arises here, reaction involving cleavage of OH bond. It means alcohols gives two kinds of reactions like ROH, in which proton released, and in another ROH, that is OHI. OH ions released. Then proton released, and then OH released. In such a way, there are two kinds of reactions. Now, more of this First of all, I would like to discuss reactions involving cleavage of OH. Reactions involving cleavage. Cleavage means to break the bond. Cleavage involving cleavage of OH. This one. OH bond. Cleavage of OH bond. Which can break this bond. The bond present between O and H. The reaction involved in presence of OH cleavage. Order, first of all, order, then primary, secondary, and tertiary. So, primary alcohols easily secondary alcohols, then minimum tertiary alcohols. Primary C2H5OH. Here is this bond will break faster. That is fastest. Break of OH bond. Then C2H5 C2H5, then OH lesser than this, and then C2H5 CH3 OH. There is a poor cleavage. You remember, exam point of view, if primary alcohol that is very fast reaction, it will give OH. For an example, if you are going to react C2H5OH with Na, that is faster. If you are taking C2H5 CH3OH plus Na, that is poor. Because here more it will prefer to break this bond, not this, and here is the bond will break this one. Here is this one. So this is the reason the sodium will react with this is the fastest, and with this is the poorest in the cleavage of OH bonds. Sorry. No, next. What is the reason for this? Here is the reason for this. Like C2H5OH. As it is electronegative, it will take electron from hydrogen as oxygen is electronegative. It will take electrons from hydrogen. It will take electrons from hydrogen and get polarized due to inductive effect. It is easy to free hydrogen from OH bond in primary alcohols. In primary alcohols. So this is the reason primary alcohols are easy to react with to cleave this H bond. So this is the reason. Now, if you will do a reaction of alcohols, reaction of alcohols with sodium metal. With sodium metal. So this is that kind of reaction. It will remove H ion because sodium is basic in nature. As we know, the first group elements are basic in nature and alcohols are slightly acidic. Okay, you got it? When it is slightly acidic, so they will react with C2H5OH. C2H5OH, then plus 2Na. 2Na. It is basic in nature. Then you will get 2C2H5ONA. That is sodium ethoxide. Sodium ethoxide, you got it. Plus, you will get a certain amount of hydrogen in gaseous form. The order of acidic strength of alcohols. The order of reactivity of sodium, already I explained. The order of reactivity of alcohols with sodium metal. With sodium metal. With sodium metal, that is primary alcohols, secondary alcohols, already explained, and tertiary alcohols. And tertiary alcohols, you got it. Already. Reaction with other metals, you can take either hydrides or metal hydrides. No. Reaction with metal hydrides. Reaction with metal hydrides like MH. Example like NH, sodium hydride, MgH2. So this is the metal, this is the hydrogen. So we can take MH. Like C2H5OH, when it will react with MH, that is metal hydride. So same way, you will get metal is here, C2H5ON. plus H2. Example, C2H5OH and like sodium hydride NH, then you will get C2H5ONA. Here also H removed. There is the cleavage of H in both cases. Na plus H2 gas released. When metal hydrides or metals react with alcohols, they remove the hydrogen from oxygen present in alcohols. Already I explained. Now, reaction with Grignard reagent. Very, very important. How you will prepare the Grignard and what compound you will get. Reaction with Grignard reagent. Because Grignard reagent acts as base, reaction with Grignard reagent. Reaction with Grignard reagent. As Grignard reagent, as GR act as base, as GR act as base, it will react with alcohols and give alkanes. Give alkanes. Likely ROH plus RMGX. So this ROH, because it will remove H, it is basic in medium, it is acidic in medium. You will get RH plus ROMGX. ROMGX. C2H5 C2H5OH, when it will react with CH3 MgBr, this reaction occurs in presence of ether always. This kind of reaction occurs in presence of ether, then H is removed, already I told you. These are reactions occurs due to removal of H from alcohols. This one is ethanol. This is GR, this is the Grignard reagent in presence of ether. When this reaction occurs, then you will get CH3 much CH4. CH4, then C2H5O MgBr. You got it. Then, now, reaction occurs due to removal of OH bond. Reactions involving OH removal from alcohols. Such kind of reaction generally occur dehydration or elimination of water molecules. Okay. Let's one or two more reactions. The reaction involving OH removal. First of all, one more reaction I want to write. One more reaction. Reactions. Later we will discuss. One more reaction for H group. Esterification. Esterification, very important reaction. Yes, esterification. In case of esterification, you are getting R C O OH. This one is acid. When it will react with alcohol, HOR. In presence of acidic medium, reaction is reversible here. Then you will get R C O R. This ester, and this one is H2 moves out plus H2. Name is, this is the ester you got. This is the ester. The reactivity order. Reactivity order will be CH3OH, primary alcohol. Again, heavy alcohol, these are the primary, CH3, CH2OH. Then secondary alcohol, CH3, twice, CHOH. And then one very poor tertiary, CH3, thrice COH. This is the order of reaction. Sometimes you will get in examination CH3OH reaction with this. Which one is faster? Question can be asked in the order of this. Once you will react with this, once you will react with this, once you will react with this. Then good quality of esters you will get from in both this and this. Both are 1 degree. This also 1 degree. So good quality of esters you will get by 2 reactions. These are the primary alcohols. The reaction mechanism of esterification is very important. Generally asked in the exam. Mechanism of esterification. Mechanism of esterification. This is the reaction mechanism. How this reaction happens? Like R C O OH. Then H you will get from acid. From acid H2SO4. So it is electronegative, the electropositive character, electron density, it will come with this. Then R C OH and then OH in such a you will get this. Next, resonatically, this carbocation is stabilized R C OH and then OH. This is resonatically stabilized. Then here is R OH. Already in previous reactions we have done in previous. This is the electron-rich species, and this electron-rich species as nucleophile, it will act on this. It will go with this one. Now, similarly, you add to this R, C as it is, you have to write OH. You can take it on top. Then this OH you can take here. This you have to drink of this O, this H, and you can take this R. This lone pair of this one is this, and here is carbocation, it got it. And lone pair of this one is this one. Now this proton get free, leaving electrons back, and now again attack on this. N R C OH, and then it's OR, you are getting, and then OH2, because it won't be this one. So proton is here. Now it will gain electron from this H2 modes. Then R, C, here is OH, this one is, then OR, carbocation plus H2. Next, this is stabilized. This carbocation will move. Electron will come here. Then radioelectrical stabilized. You will get R, C, OH, and then OR. No, this is the proton. This hydrogen will get proton and then move out. Then R, C, OH, and then O plus this proton created. This is the same proton. This is the same proton you have used here. This is the same proton. Again, I will repeat once within 2 minutes. RCO, this is the ester. It is polar, more electronegative. It will give lone pair electrons. And the proton it will gain from H2SO4. And you will get the cationic form of acid. Radioelectrically it is stabilized. It will give stable carbocation and it shifts this proton, this carbon atom. This carbon atom, carbocation, it will gain lone pair of electrons from alcohols. Alcohol acts as here nucleophile. In this nucleophile, that is the addition product, that is the unstabilized. So this proton will give its electron to this oxygen and get freed and comes to this oxygen. It is having the lone pair of electrons. Then you will get R, OH, OR, and then OHN. Similarly, RCOH and OR you will get. Then RCOH and OH2, this proton is given to here, and you will get the acid. Okay. So this is the reaction mechanism of ester. This is the ester. This is the ester. OR. This is the OR. So this you will go to the OR, ester. This is the ester. This reaction is very, very important reaction mechanism. For many reactions, you would like to this reaction application. Once more, you have to rejoin. And the next video, I will not record because I will give doubt of this, whatever I told you today.